Okay, so in this lesson, it's all about negative exponents. And I know I covered a tiny bit on the last lesson, just because I know some of you guys were going there with the rules. But just as a more in-depth exploration, Alex is going to have you do a lot more problems with negative exponents. So there are a lot of problems here. I've done 2 of each kind just so that we get an idea, okay, except for the beginning ones. So you have a little more practice, and highly recommend that what you do is maybe pause and try to do the second problem and then see how you do. Okay. All right. This is actually a definition. A to the 0 is equal to 1. Any number, A represents any number to the 0 power is equal to 1. I want to show you where they get this from. Check this out. So, let's take a real number. Okay, something like 9. Let me do 3 actually. Let's do 3 squared. So 3 squared equals 9, right? 3 to the first power equals 3. I could have done 3 cubed too. 3 cubed equals 3 times 3 times 3, which is 27. Now what's happening each time? Each time they're dividing by 3, right? Because this is a multiplication by 3. Okay, so 3 cubed is 27, 3 squared is 9, 3 to the first. Now, 3, 2, 1, the next one to go is 0. Well, what's 3? Look at 27 divided by 9. 3 is 9. 9 divided by 3 is 3. What's 3 divided by 3? 1. And there's where you get the definition of 0. Okay, then we're going to pop on to the next page. What would this one be? It's going to be 1 over 3 because 1 divided by 3, here's a pattern. Math is nothing more than a study of patterns. 1 divided by 3 is 1/3. What's 3 to the negative 2? It's going to be 1/3 divided by 1/3 or times 1/3, which is 1 over 3 squared or 1/9. Do you see what's happening with these negative exponents? It just means that they're in the wrong spot. They need to go down there. Okay? 3 to the negative 2 is equal to 3 squared, 1 over 3 squared. Okay? These are definitions. It's easiest if you remember them rather than have to do this every single time, but this is where it comes from. So A to the negative m, that could be any number, is 1 over A to the m. So all it does is if you put it underneath a 1 or on the denominator, it becomes positive. Okay? So this is 1, and this is negative 1. Why? Because the negative is outside the base. The base of the 0 is 6/7, so that's negative 1. Moving on. Okay, take a look at this one. Now, this doesn't look like what we just had. This is negative 2 on the bottom. It says, rewrite the following without an exponent. Okay, that means you need to figure out what this is. Well, there's a couple ways of doing it. One is the more complex definition one. That's this one, okay? And then what is the definition of 10 to the negative 2? It is, I'm going to circle it so you know. Okay, so 10 to the negative 2 becomes 1 over 10 squared. That is the definition, okay? The definition means to do that. Well, oh my gosh, well, what if you were to do this? A number divided by a fraction means to multiply by the reciprocal. So we got to put 1 over 1 times the reciprocal of this, which is 10 squared over 1, which is 100. Okay, that's the definition way to go, and that's a lot more complex. I just remember this. If I've got 3 to the negative 2, that's 1 over 3 squared. If I have 1 over 3 to the negative 2, it means that, look, the negative means it's in the wrong location. It shouldn't be on the top. It has to go to the bottom. So if there's a negative in the bottom, it means it needs to go to the top. So this becomes 9. But if you wanted to go through all the fractions, that's where that comes from. Okay, fraction over fraction multiplying by the reciprocal, and you get that. Okay, let's take a look. Okay, take a look at this one. Okay, it says evaluating an expression with a negative exponent, positive fraction base. Okay, so it says without an exponent. It means you're supposed to get to numbers. Okay, definition of negative. A little more complex, right? It's 1 over 4/7 squared. So that would be 1 over 16/49, because 4 times 4 is 16, 7 times 7 is 49. I don't think I gave you that rule yet. A to the m over a to the n. Wait, no. Sorry, my bad. I'm going to do this differently. Sorry, here we go. Okay, this is the rule of when you have a power to a power. So if I've got a over b to the m, okay, that's a to the m over b to the m. In other words, the exponent feels like it kind of distributes to both. That's what we did right here. 4 squared is 16, 7 squared is 49. Now we have a 1 over a fraction, so you would have to go 1 over 1, so 1 over 1, times the reciprocal, 49 over 16. And that's your answer, 49 over 16. Now, I wouldn't do it that way. There's another way of doing it. I'm going to show you multiple ways, you guys, and so don't let me confuse you. What you want to do is pick the way that makes most sense to you. This is the definition, okay? We could also go this. You could go 4/7 to the negative 2 and use this rule right here, and instead go equals 4 to the negative 2 over 7 to the negative 2. And then that means it's in the wrong location. Okay, well, so we would go 1 over 4 squared times 7 squared over 1, if you will, right? Because this means it goes on top. That means it goes on the bottom. Okay, and you would get 49, 7 squared over 16. Okay, that is how I personally do it. Actually, that's not even true. In my brain, it goes like this. I flip it. Oops. In my brain, I flip the fraction first and then change this to a positive. It's a whole other kind of level of trying to, it's basically doing this in your head kind of thing. Okay. But these are the rules, and this is how you get there. Okay. Let's try another one. Pretty sure I gave you another one of these. Nope, this got a negative integer. All right. So let's take a look at this one. It's got -5 to the -1. Nothing has changed. If you need to block this out, it's totally fine. But it's 1 over -5 to the 1. -1/5. That's it. Okay. Did I give you guys another one of these? Yeah, no. But if you had one, -3 to the -2, that's just 1 over -3, keep it in parentheses, squared, which is 1/9. Okay? Always remember to keep your bases in parentheses so you don't screw up. Okay. Without a negative exponent. So now we've got to get things in the right spot. Okay, notice this negative has nothing to do with this exponent. Okay, it's v to the -5th. If we were going to use the definition, and we're going to get all tangled up in there, in these, what do you call it? In these multiplication of fractions. Okay, by definitions, come on over here, eraser. Okay, goes like this. You times 1 over v to the 5th. And you would get 1 over -5 over, okay, because remember this is over 1, multiply across v to the 5th. Well, again, 1 over 1, we can flip it. 1 over any fraction is just going to flip the fraction, if you guys haven't figured that out by now. So this is going to end up being 1 over 1 times v to the 5th over negative 5, which is negative v to the 5th over 5. And that's the answer. Okay? I personally just do this. I see that there's a negative there. That to me indicates it's in the wrong spot, and I just move it to the top, v to the 5th, and I'm done. So I don't have to go through any of this stuff because I remember that that is 1 over v squared, and that'll pop it to the top. 1 over any fraction is going to be equal to the reciprocal because we're going through this whole process here. This is handy dandy to know. Anytime you have a fraction underneath the 1, it flips the fraction. Okay, moving on. All right, again, without a negative exponent. Okay, so again, to me, this just means it's in the wrong spot. The numbers don't change. We didn't do anything to the real numbers, so we leave them there, m to the 4th. And then we never leave the negative in the denominator. We pull it up to the middle or to the top. Okay, and you don't really need that 1 either. Okay. All right. Introduction of the product rule with negative exponents. Just multiply like we did before, which means we add bases. Like, ooh, what do we do? Ready? X times x equals x squared. Okay? X times x equals x squared. What did we do to the exponents? We added them. Same here. Doesn't matter that they're negative. Just add them. 5 plus 1 is 6. 6 minus 9 is negative 3. It's x to the negative 3. Okay, but they said write your answer positive exponents only. Okay, so that means you have to use the definition and you write 1 over x to the 3rd. Don't forget the definition of negative exponents. Okay, coming back here. Next one. Let me get my pen situated right. As I did that, I lost it. Let's try that again. I did not want to open up my my drive. Sorry about this. Take a break. Wave this for the summer. Okay, let's see. Ready? Okay, here's another one. Product rule with negative exponents. Just add them. That's all you have to do. So we've got, come on, honey. Okay, x to the negative 6 plus 7 is 1. 1 minus 2 is negative 1. And that right there is the definition of negative exponents. 1 over x to the power of 1. You don't need to put the 1 because any x is to the power of 1. Moving on. Okay, quotient rule with negative exponents. Here's the first type, easiest one. Okay, so you're going to be using the same quotient rule. Remember, a to the m over a to the n is equal to a to the m minus n. In other words, we're subtracting. Same thing. So you rewrite it. P to the negative 1 minus 1. Subtract that bottom one. That becomes p to the negative 2 or 1 over p squared. Okay? I don't actually think of it that way myself. I think of that negative 1 is positive 1. That negative 1 is in the wrong location. So I move it down and I have 2 p's on the bottom. So I get 1 over p squared. I'm showing you my way just in case you think like me. A lot of people don't. Okay, here we go. This is y to the first power using the subtraction rule, or division rule rather. 1 minus negative 5 equals y to the 6th. Pretty simple. I don't think of it that way. I think of it as y to the negative 5. There's 5 on the bottom that don't belong there, so I bring them to the top. And there's 6 on the top now. All right. Here we go. Power rule with negative exponents. Nothing has changed. A to the m to the n is equal to a to the mn. Okay? So look, you get y to the negative 12th. Multiply these two numbers. But we have to use no negative exponents. Definition of negative exponents. Put it under 1. And you're done. Okay, here. Multiply them, v to the 12th, and it's positive. So we're good to go. Moving on. All right. So we're going to use this rule. A to the m over b to the n to the x. I don't know it doesn't really matter what letters I put. Is a to the mx over b to the nx. In other words, we multiply these and we multiply these exponents. Same rule, but just one on the top and one on the bottom. Okay, numerator and denominator. So here it's going to be b to the negative 6 over, you know what? Let's not be hasty. Let's go ahead and write it correctly. Let's go ahead and use the rule and write it correctly. So I'm going to go b squared e, oh my goodness, squared to the negative 3 and 3a to the 4th to the negative 3. That's the rule. Okay, then we're going to use this rule, the exponent power of a power rule, b to the negative 6th over, and then this one, remember, you have to do 3 to the negative 3. It goes to every single one inside there. A to the negative 12. Okay, so we still got to simplify it because only positive exponents. So b to the negative 6 means it needs to go on the bottom, b to the 6th. A to the negative 3rd means it goes to the top, a to the 3rd. And then, oh wait, that's not a, that's 3. I don't know what I was thinking. It's 3 to the 3rd, but it's 3 to the negative 3rd. Hello. So 3 times 3, again, hold up 3 fingers. 3 fingers. Okay. Oh, those two aren't held up. Okay. I know that doesn't make any sense, but you go 3 times 3 is 9 times 3 is 27. 27, but it's to the negative 3, so it's 1 over 27, which means it will eventually pop up there on top. A to the negative 12th means it goes on the top. A to the 12th. And that is your answer right there. Okay. Okay, last one. Power rule with negative exponents. Same thing applies. Okay, this can be rewritten as negative 3 squared, okay, times b squared times c to the negative 5th squared. Basically, you're distributing to every single one, and you can consider this one your base. Okay, so that's going to be negative 3 squared is negative 3 times negative 3, positive 9. B to the 4th and c to the negative 10th. Well, we don't want negative exponents, so we got to put that c to the 10th on the bottom by the definition of negative exponents. There you go. And that is it.